Global warming and carbon dioxide. You know the story. It's flirting with 400 parts per million in the atmosphere, which to most people means nothing. But that was concluded via ice cores and other data sources, and that temperature has been correlated with important greenhouse gases for hundreds of thousands of years. Just looking at temperature and CO2, that match is remarkable over those time frames. But I have a confession to make. I'm hiding part of this chart over on the right, and it's the most important part of the data. Here's the whole thing, at least the last one I can find updated. The uptick began with human pollution. We know CO2 is even higher than this now, and the global temperatures have indeed continued on par for the course without regard for the rising CO2. In fact, it was considered something of a small miracle in these circles when the IPCC appeared to concede 1 point, even though their position on climate change remained firm. And that's an important distinction: climate change versus global warming. Indeed, even without major total warming recently, there have been extreme heat events, but cold as well. Europe and parts of Russia and India have seen terrible winters in the past few years, as harsh as some of the recent summers were hot. And now, indeed, their extreme has swung the other way for a good portion of the 2013 northern summer. The United States have been mostly on the warming end. In fact, 2012 was impressively warm from January through most of the latter months. But as of August 30th, 2013, the US has been setting more cold records than heat records, even as the average total temperature does continue to increase slightly. The US saw tremendous floods in 2011, almost as a side note to a number of tornado records falling and hundreds of deaths. 2012 brought the drought, had January tornado outbreaks with wild heat. Then, tornadoes became sporadic in the usual active months, and so far 2013 has been remarkably low for tornado output, and our season began much later than normal. The north central states have seen more than usual, along with Australia and New Zealand. The science of CO2 heating mechanisms via things like insulation is too large a topic for this presentation, but it is incontrovertible. However, so are some of the well-known cooling mechanisms, like the one described by NASA here, which we'll discuss in more detail in a few minutes. For now, simply remember that the Earth's temperature might not be so sensitive to carbon dioxide. When humans began pumping CO2 into the air, the correlation with temperature broke. We'll come back to those cooling rules of CO2, and also remember that the climate extremes seem to be swinging in all directions. In fact, there is growing discussion about a possible impending mini ice age. We have been tracking a solar shutdown at our YouTube channel for nearly 2 years. The experts have recognized mechanisms for such a shift, and concerned parties range from individuals at NASA and the NSO, who potentially see the next cycle without sunspots, and numerous others. The shutdown, oddly, is not a matter of normal everyday irradiance and luminosity, but one of magnetism. The entire sun emits light and radiance, but the sunspots and emanating magnetic fields have been fading consistently. We are at the doorstep of our next cycle, which may be extremely weak. For more information on these solar mechanisms, see How to Watch the Sun. Just put it into any search engine. The practical effect of fading magnetics means less energetic flaring and solar plasma interaction. The mechanisms for a cooling trend are described by Irish scientist Dr. Elliott. He explains why we are still showing warming signs on the potential path to ice. In truth, there is another reason Earth sees heat. The energy transfer from the sun is constant over most of it, but when the magnetic fields of the sun are missing, the coronal holes come out. Another in-depth topic, but simply, these increasingly present masses contain alpha waves that more effectively transfer energy to the planets than the surrounding fields. This outward force is powerful enough to push solar wind particles out ahead of it like an electromagnetic shovel bunching up the solar snow on the blade, characterized by spikes in solar wind density just before the speed of the particles rises to reveal the extreme outward force of the coronal holes by comparison. The takeaways here, besides a potential ice age, involve a method for increased energy transfer via coronal holes, explained by NASA and tracked at our YouTube channel for years. But we are certainly not done discussing the incoming energy from space. While CO2 sits suspect in the waiting room and coronal holes showing up regularly, we must consider a third point. Earth's magnetism has benignly remained steady for quite some time, until now. Let's start with Earth's magnetic North Pole. Since the world became a sphere circling the sun in the eyes of man, the pole has chosen to reside those few hundred years in northern Canada, offset from the geographic poles as usual. But since the late 19th century, the pole has shifted faster and faster towards Siberia, now clocked around 40 miles per year. The South Pole is shifting in kind, but at a much slower rate. The more important aspect of Earth's magnetic shift is in our magnetosphere, our magnetic shield, Earth's interface with deadly energy from space. Here it is. Pink is good back in the 1600s, but the blue, indicative of weaker fields, has crept in over time, and according to NASA, the field is 10% weaker than it was in the 19th century, which is about the same time those magnetic poles developed a lead foot for the accelerator. Now, this is not to say we're going to fry, because there is no evidence to suggest we ever lose our field entirely over time, even in a complete flip. But what happens when you consider the state of our shield in terms of what we've already learned? Here is the official US government take on the climate. The sun, unchanging up top as a climate factor, and they use the bottom lines to correlate CO2 and temperature. Their solar claims are based on that luminosity and general irradiance described earlier, which indeed varies only 0.1% over an 11-year cycle, which is the change you see represented here at the top line. But you already know that there's much more than just the UV light emitted across the surface. Some of these even do a better job juicing up the planets. In addition to ignoring those things, we see no accounting for a weaker magnetosphere, which plays at least some role in nearly every energetic interaction of Earth, but least of all, the irradiance they've chosen to highlight. There's more. As the solar magnetic fields are weakening, the sunspots decrease in size and frequency. The sun's magnetic shield weakens in kind. We have already examined the possibility that these fields will continue to weaken and remain weak. Just like the Earth has its magnetosphere, the Sun has the heliosphere, extending far out past Earth and even Pluto. The galaxy is a harsh place, and the Sun's massive shield protects all the planets from cosmic rays. But it's fading with the Sun's magnetics. The mechanisms for ozone destruction and climate forcing with cosmic radiation are well studied, and you can find some good links in the publicly available citation list. CO2 and temperature are astoundingly correlated over thousands of years, but human pollution broke that trend years ago. We'll get to the cooling mechanisms in a moment, but the last few hundred years have actually been remarkably calm. The magnetic poles are only really kicking their shift into gear in the late 19th century, and now NASA says our magnetic shield from space is 10% weaker. Weaker against energy from the sun of all types and against galactic radiation. Due diligence reveals no evidence of these factors in widely cited studies on the climate, nor on the official government websites. And we are now left with the most glaring point. If these things are true, we should also be seeing changes on the other planets. In 2012, ESA's Venus spacecraft detected that the rotation speed of Venus had slowed. Its day is 6.5 minutes longer. We recently learned of its latest finding. The wind speeds on Venus are increasing, already up 33% over just the last 6 years. Imagine if 2019 had 200-mile-per-hour hurricanes with regularity. Another planet slowing its rotation is Saturn. The most impressive changes there, however, is the set your watch storm on Saturn every 30 years that lasts a few weeks, except this latest episode was a decade early, a Leviathan, and lasted for 200 days. Jupiter is the most changing planet. We've long had scopes capable of seeing his spots. One like Red Jr. was a novel appearance, however, in our time of viewing. So was losing a stripe. This isn't like a storm system. This is a systemic shift. And now, after decades of listening in radio wavelength, Zeus sings a new song for those willing to listen. We've been watching Uranus for a long time, but we just recently were able to image its auroras. National Geographic ran this article in 2007. The data surrounding warming of the planets in our system is both vast and taboo in the mainstream science community. Some of those changes would have major implications if they happened on Earth. Our climate and geomagnetic shifts are undeniable, but in many ways tame in comparison to what we see on other planets, and especially what we see on the Sun. I'd like to share with you some of the less known changes on our planet. The critical frequency of the F1 layer is significant for radio communication, but it is indirectly indicative of energy at that layer of the atmosphere. It boringly goes up and down slightly with the solar cycle, maintaining a nice arc, until 2007, when we began to see signal degradation of stronger and stronger propagations. It's spiraling out of control, and they just took this data stream offline in the spring of 2013. There is no replacement. Noctilucent clouds were first seen around that same time Earth's magnetics began breaking, and have been a rare summer polar phenomenon until recently. They've exploded earlier, stronger, longer, and later, baffling scientists. These are the highest clouds there are, directly below the thermosphere. Popular science is beginning to blame CO2 for their recent explosion, and also for the collapse of Earth's upper atmosphere, which they claim to otherwise not be able to explain. However, NASA has claimed that the lack of flares at solar minimum collapses the atmosphere. Rather, it takes flares to prop it up every solar maximum, as it's always trying to collapse. Those same flares are what we're lacking with the solar magnetic shutdown we discussed earlier. But let's just assume for a moment that our highest layers are collapsing and exploding with noctilucent clouds because of CO2 and nothing else. The aforementioned cooling mechanism of CO2 only works up there. CO2 is one of the two most efficient coolants in Earth's thermosphere. In this example given by NASA, it helped deflect 95% of a significant geoeffective solar event. They have described intake events that could power major cities for days or longer. As previously stated, humans are not helping our climate with much of what we're doing. But this event truly appears to have begun long before humans ramped our pollution, which actually can only be tied to breaking its perfect correlation with temperature. And I'm still waiting for a totality of the circumstances explanation from our climate experts. Why would they do this? Why blame us? And most importantly,